The fuel mass carried by a commercial aircraft can represent about half of its total mass at takeoff. Carrying and pumping this large amount of fuel, in addition to safety regulations, requires complex systems which must ensure uninterrupted fuel flow during flight. Predicting the fuel system's behavior early in the development cycle enables you to optimize the key performance indicators for different attributes, such as fuel distribution and refueling, tank inerting, and coupling with vehicle dynamics. This mock-up is a replica of a fuel system in an aircraft wing. It is composed of 3 tanks, separated by ribs, vents, and drain holes, as well as flap valves, and features a balance pipe and vent pipe. To simulate the aircraft's pitch and roll, there are 2 electromechanical actuators. Finally, you find sensors which give information about the fuel rig operation, such as the liquid level in the outboard tank. This fuel rig has been made using SimCenter solutions for subsystems and component sizing, as well as architecture trade-off. With SimCenter AimSim, we run multi-domain simulations early in the development process, which allows us to validate the concept against the initial requirements. In parallel, we size the actuators so that they can cover the desired pitch and roll amplitudes. Secondly, we build a complete CAD model in SimCenter NX based on the early system simulation results. When required, we can zoom in on the component level. For instance, we can apply the actuation loads extracted from SimCenter AimSim to a finite element analysis model of a mechanical part within SimCenter 3D to find the best compromise between actuation speed and structure durability. In parallel, the controller is modeled and simulated, making the final integration and calibration straightforward. At the end of this process, we have a complete digital twin of the operating demonstrator in SimCenter AimSim. On the one hand, it co-simulates the mechanical parts and the actuators in 3D, and on the other, it performs all the hydraulic calculations. The time to build this digital twin is greatly reduced thanks to the standard library of models available. A plugin automatically generates the geometrical description of the fuel tanks and ribs from the CAD model. From SimCenter AimSim, we can interactively operate the physical bench. Both the physical and the digital versions react to changes in attitude of valve opening and closing. The liquid level measured by a sensor is fed back to the controller and can be compared to its virtual counterpart. The setup shows that the fuel system modeled has a good level of fidelity and is running fast enough to be operated live. In summary, using SimCenter solutions enables you to accurately predict the performance of a complete system. Virtual prototyping is a reliable, quick, and time-efficient way to analyze and predict system performance even before the aircraft wing is built.